Hello students, today we'll be looking at converting between recurring decimals and fractions. So by the end of this video, you should feel more confident with converting from decimals into fractions using both methods. We should also feel more confident converting fractions into recurring decimals. So the first method for converting recurring decimals into fractions works when both numbers, or every number, so it could continue, is recurring. It only works for this style of recurring decimal. And the way this works is, so the first part is to write x equals 0.17, or whatever your recurring decimal is. And then you need to multiply it by a power of 10 where every recurring number, so the first set of recurring numbers, is past the decimal point, so it's just before. So we want 17.17. Now we know that if we multiply by 100 we can actually get that result. So you can put 100x equals 17.17. But we're still stuck with these two recurring decimals here. So if we take, but we know that 1x, so this is 1x, that's what x stands for, is equal to 0.17, then we can subtract that from 17.17 and actually just be left with 17. So 99x would equal 17. We did that because we did 17.17, where this is recurring, subtract 0.17 recurring, and that just left us with 17. Here on the algebraic side, that was 100x minus 1x, which was 99x. Now if we want to rearrange this, so we have x as the subject, we'll have x equals 17 divided by 99. And that's our answer for the first part of this question. This is left as a fraction, and this would get you the marks. So here is a question for you to try now. If you'd like to pause the video to attempt the question, please pause the video now. Okay, so now I'm going to go through the answer with you guys. So the first step we said was to write x equals, just so we know that this is the value of x. Then we want to get every single recurring decimal that's past the decimal point on the left side of the decimal point one time. So that would leave us 27.27 recurring. And so what would x need to be for this to be true? Well, it would have to be 100x. So 100 times 0.27 recurring would equal 27.27. And to remove this two recurring points here, we can subtract x. So 27.27 subtract 27 recurring, because these are both recurring, and that would leave us with 27. So we would have 99x, because we just did 100x minus x, equals 27. And if we rearrange this, we would have 27 over 99. And that is our fraction. So if you would put this into a calculator to check, put 27 divided by 99, you'd actually get 0.27 recurring. So the second method works when only some of the numbers after the decimal point are not recurring. So here, 1 is not recurring, so this is a sign that we have to use method 2. Only the 7 is recurring, which means this 7 continuously going forward. So the first step is to make sure that we can get all of these points on the left side of once. So we'd want to get 17.7 recurring, right? So this is x here. So what would we have to multiply x by to get 17.7? Well, that would be 100. X equals 17.7 recurring. Now we want to get rid of this recurring decimal here. So one way we can do this is if we do 10x, which will equal 1.7, and we subtract these two algebraic parts, we should actually end up with a non-recurring decimal. So if we try this out, 17.7 recurring minus 1.7, so what we get here is 0.61. So we actually get 16. So 100x minus 10x would give us 90x, and then that would equal 16. And then if we rearrange, we should get 16 over 90 is equal to x, and that would be our final answer. So here are some questions for you to try. If you'd like to pause the video to attempt the question, please pause the video now. Okay, so now I'm going to go through the answer. So remember, we're using method 2 here because one of the decimals, or one of the points past the decimal, is not recurring. Only the 4 is recurring. So the first step in these questions, always write x equals 0.14. Then we can write, we want to get all of these points before the decimal just one time. So 14.4 recurring would have to multiply this by 100 to get that. So 100x would equal 14.4 recurring. But we still want to remove this decimal point here, the bit that's past the decimal because it's recurring. So the way we do this is we get 10x, which equals 1.4 recurring, and then we subtract 10x from 100x. So 100x is 14.4 and 10x is 1.4 recurring. And so if we have a look at this and we do the subtraction, we get 0 and we get 3, 1. So now we've got 90x is equal to 13, and if we rearrange to make x a subject, we get x equals 13 over 90. Hopefully you got that right. If not, have a look just back in the video and see if you can see where you went wrong. Alright, so fractions into recurring decimals. So the aim when trying to convert a fraction into a decimal is to make the denominator entirely out of 9s. Now if you're familiar with equivalent fractions, you should see that this, to make the denominator 9 here, or entirely out of 9s, we could multiply this by 3, because 99 is a multiple of 3. So if we were to do 33 times 3, we would have 99 as our denominator. But to remain this equivalent, we also have to multiply the numerator by 3 also. So 17 times 3 is equal to 51. Now this is the fairly nice part. So everything that is the numerator, this is actually the recurring part of the decimal. So our recurring part of the decimal now is 0 point and then 5, 1 recurring, which would be the same as 5, 1, 5, 1, 5, 1, and so forth, continuously going. So here's a question for you to try. If you'd like to pause the video to attempt the question, please pause the video now. Okay, so now I'm going to go through the answer. So remember, we want to make our denominator entirely out of 9s. So is there an equivalent fraction where we can make the denominator entirely out of 9s? Well, we'll see if there's a multiple of 11 that goes into 9. So 11, 22, 33, 44, 55, 66, 77, 88, 99. So that was times 1, times 2, times 3, times 4, times 5, times 6, times 7, times 8, times 9. So 11 times 9 would actually give us 99. So that's multiplied by 9. So to remain this as a true and equal equivalent fraction, we have to multiply the numerator by 9 also, which will give us 36. And we said whatever the numerator is the recurring part of the decimal. So 36 over 99 is actually equal to 0 point and then the numerator, so 36, and both of these parts are recurring. Alright, thank you very much for watching. For more videos, please visit www.gcsemathresources.co.uk.